Hi, I am Abhishai, Solution Architect at Converge. Converge is a compute-agnostic AI operating system to build and deploy AI on any infrastructure built by data scientists for data scientists. Converge enables you to connect all of your resources across any cloud and on-premises and allow you to run diverse AI workloads within the same pipeline. In this demo, we will have a quick walkthrough of creating EKS cluster using the new DL1 instances powered by Habana Gaudi AI processor. Then, we'll see how it's easy to train model with Converge by leveraging a Gaudi AI processor with just a few clicks. This is the first AI training instance that is not based on GPU, give you up to 40% better price performance than existing GPU. Let's go. When we first log into the platform, we land on the project page when you see all of the project that you created. Now let's create an EKS cluster using Habana DL1 instances. First, we go into Compute, select the resources. In the upper corner, select a new resources and choose AWS EKS and press Next. So first, we give it a resource name. We call it HPU cluster. We choose the Kubernetes runtime version. Here we need to specify the AWS role. So if you don't have any role, you can click on create a role, and this will be directed to your Amazon environment. In this case, I'm going to choose my ephemeral role here. Here we choose the relevant region. At this moment of recording, DL1 instances are available in the US East, North Virginia, and the US West, Oregon. So in this case, I'm going to choose the US East one. And under the node group, we are going to select the instance type, which of course will be the DL1 24x large. For those of you who wants to use Spot instances, you can leverage Spot instances for your node group. And of course, also Converge offer out-of-the-box auto-scaling for the node group feature, where the nodes are not live until jobs start to run. Once a job is finished, we will scale down the node until we need it again. Here we change the desired capacity into 1, and I change the volume size into 200. The availability zone, just choose any random availability zone and hit on next. So before we press on create, as you can see from the operation side, Converge will summarize the Converge stack that comes along with the cluster, whether it is a network, a driver, and the observability side, which is pre-configured accordingly with Converge. Let's hit on create. And as you can see, the status is initializing right now. We see that EKS cluster creation is in progress. Let's look at the cluster that we already got up and running. So we have the HPU EKS. Here is the details of the EKS cluster that we got up earlier. Here we can actually see the status of the cluster and the worker type. And of course, we can see the logs and the health checks for this particular cluster. Let's click on the View Dashboard. So inside the dashboard, you can get a complete overview of how your resources are allocated and how they are being utilized. Along the top of the page, there is an overview of the current status of all of your jobs and compute allocation over your entire organization and all of your compute resources. Under Live Resources graph, you will provide the live insights into the allocation and the utilization for each of your compute resource. Each compute resource has a line representing the allocation and the line representing the utilization for the CPU, GPU, HPU, and memory. So you can filter out those metrics when we're running the model. So let's go back to the projects. Once the cluster is up, we will go to compute and choose compute templates. And Converge provides several different compute templates, which is predefined sets of compute resources. You can modify these and add new compute templates with no special effort. So let's add the compute templates. We choose the earlier provisioning resource that will be created, which is the HPU EKS. Here we can select a different type of a new template. In this case, we use the regular one. We give it a name. We call it HPU Gaudi. And under specification, we specify the amount of CPU. I give it a 4. Memory, I give 8. We don't have GPU, we have HPU, so I set it to 1. And I can hit Save button. In the most instances, you configure the compute you need once in the form of compute templates at the system setup. So these become available across your entire organization. Now let's create a project. And a project in Converge allows a community of users to organize and manage their content in isolation from other communities. A project can include files, workspaces, experiments, flows, application, dashboard, serving, artifacts. So we start with a new project and we give it a name. Let's call it TensorFlow example, because we are going to use an example. How are we going to use this project? We need to decide if we're going to connect our Git repo or are we going to upload the files. In this case, I'm going to use Git repo. And this Git repo, which is the Habana deep learning example for training. As you can see here, this repository is a collection of models that have been ported to run on Habana Gaudi training acceleration. So we are going to clone that repo. We can close that. Let's put the Git repo URL here. We're given the branch name, and we hit on save. Once we hit on save, we can actually start our project. So before we run our experiment, let's go over our code. And here, as you can see, under the Habana model references, we have an example, Python example using TensorFlow. So in our case, we ported a sample Python script represent just a TensorFlow model to Gaudi. So as you can see on the line 3, we imported the function to enable Gaudi, and at the line 5, the function imported earlier is called to enable Gaudi, that is registers as a HPU device in the TensorFlow and the Habana optimization. So back to Converge. Let's go to experiment phase. Now I'm going to spin up an experiment. And the experiment in Converge is a non-interactive job. uh, is the most basic and strong building block on Converge. And this is where you can probably test out your theories. You have the ability to compare multiple experiments, test them in order for you to go with them safely into the production. So let's create a new experiment. As you all see, that is asked me for a command to execute. Now, this can be any command that you could execute from your command line. So it could be a bash calling a script, a script.sh file could be, it can be a Scala, a Java, anything you like. And it actually bring up every single file as well as the command that you would use to execute. So in this case, I use the TensorFlow example py. So I'm going to specify the path for the example after we clone that. And we specify the title. And if you browse around here, we can see we have parameters. And parameters is where you can get more details of your experiments. If your script is designed to actually take arguments as parameters overrides. So then you can actually provide a key value overrides here, and those will be passed to your script at runtime. So things like batch size, epoch, anything you like can actually be overridden here and will be passed to your script. Under optimization, you can also choose to set objective and goals for optimization and hyper parameters tuning. And Converge will then actually manage that for you and display that all in the experiment panel as it runs. Datasets. This is where you can get more details of your experiments if your script is designed to actually take argument as a takes arguments from your datasets. And you can actually select data that you want to attach and use for the experiments. If your experiments depend on data sets that have been registered with Converge, then you're now able to actually specify. But at this time, we don't have any specified data sets. Let's go into environment. And this is where you can also select an environment that should be executed on. So for this training job, I want to use the new HPU DL1 instances based on the Habana Gaudi AI processor in order to leverage my model. So let's go into compute and select the compute template that we already created. We called it HPU Gaudi. As you can see, we specify the 4 CPU and 8 CPU gig of RAM and 1 HPU. So we choose that. Under images, I might want to then select a particular image that is optimized to actually execute with that hardware. And so you have a lot of choices, as you can see. So we use the latest one, which comes from Habana repo. So I'm going to choose this version. And I'm going to hit on the run button. So when running experiments, Converge automatically takes a snapshot of your code and launch a DL1 worker and install all the dependencies and runs your experiments. So we can see at the logs all the steps that that the experiment is going to do. It's going to clone the repo, going to install all the dependencies, and it's important to mention that it's run on is container based, so it's run on container. So as you can see right now, it's going to download all the dependencies accordingly. So let's wait for that. And going to run the experiment, as you can see here. Yeah, and the model start to run. So far, 1 minute, 34 seconds. It's important to mention we are now using a 4 CPU of the Gaudi processor. As you can see, we can find the loss in the accuracy metrics can be visualized, as well as the log output here. And that's it. The model has finished with 1 minute 44 seconds. So we achieved impressive result performance, throughput, and time to train within 1 minute and 44 seconds. Overall, the Habana Gaudi AI processor is designed to maximize training throughput and efficiency while providing developers with optimized software and tools that can scale to many workloads using Converge. Thanks for watching.